Hello students, welcome to Diksha Karnataka YouTube channel. Abhyas KCET 2024 mock test 6 has been released. So in this video I'm going to discuss the solution of mock test 6, question number 151 to 180. Okay, if you haven't downloaded the paper, please join the WhatsApp channel using the link which is given in the description box. Okay, yeah. So let's start question number 151. A proton beam enters magnetic field of 10 to the power minus 4 Weber per meter square. Here magnetic field B is equal to 10 to the power minus 4 Weber per meter square. Normally, if the specific charge of the proton is 10 to the power 11 coulomb per kg, that is E by m is equal to 10 to the power 11 coulomb per kg, and its velocity is 10 to the power 9 meter per second. Velocity of the electron is 10 to the power 9 meter per second. Then the radius of the described circle will be, okay, so when electron enters into a uniform magnetic field, the motion of the electron is perpendicular to the magnetic field. Okay, so then electron takes circular path, right? Electron takes circular path, right? So this is the uniform magnetic field. Electron takes circular path, right? So they are asking what is the radius of the circular path. Okay, so here the radius of the circular path are equal to mv divided by q into b. Okay, so how we got this formula? So we got this formula by equating centripetal force mv square divided by r equal to, so this centripetal force is provided by magnetic force, right? mv square by r equal to q into v into b. Okay, from this we got this formula. So now r, that is radius of the circular path, r equal to, here m by q is m by e, right? M by e into v by b. Okay, what is e by m? E by m is 10 to the power 11 coulomb per kg, right? M by e will be 10 to the power minus 11 coulomb per kg, right? R equal to 10 to the power minus 11 into v. V is 10 to the power 9 divided by b. B is 10 to the power minus 4, right? 10 to the power minus 4. Now radius r is equal to 10 to the power minus 11 into 10 to the power 9 is 10 to the power minus 2, right? 10 to the power minus 2 by 10 to the power minus 4 is 10 to the power 2. So r equal to 100 meter, right? R equal to 100 meters. So option D is the correct answer. Okay, yeah. Next question, question number 152. A charged particle with a velocity 2 into 10 to the power 3 meter per second passes undeflected through electric field and magnetic fields which are mutually perpendicular to each other. Here electric field and magnetic field both are perpendicular to each other. Okay, and here the charged particle with a velocity 2 into 10 to the power 3 meter per second enters into the electric field and magnetic field, both are mutually perpendicular to each other, and it goes undeflected. The magnetic field is 1.5 Tesla, B equal to 1.5 Tesla. The the magnitude of the electric field will be, okay, so here we need to find the value of E, right? Here the charged particle goes undeflected in electric field and magnetic field, both are perpendicular to each other, right? So what does that mean? The force acting on the charged particle is equal to 0, right? So this force is Lorentz force, right? So Lorentz force is Q into E plus Q into VB, right? Which is equal to 0, right? Q into E is electric force and Q into V into B is magnetic force, right? So therefore in magnitude electric force is equal to magnetic force, then only particle can move undeflected in electric field and magnetic field. Okay, both are perpendicular to each other. Now Q will get cancelled, right? V is given, B is given. We need to find E, right? So E is equal to V is 2 into 10 to the power 3 into B. B is here 1.5 Tesla. So electric field is equal to 3 into 10 to the power 3 Newton per Coulomb. So the correct option is C. Okay, 3 into 10 to the power 3 Coulomb. Yeah, next question, question number 153. Magnetic field at a distance r from an infinitely long straight conductor carrying a steady current varies as. Okay, here this is the infinitely long straight wire. Okay, so it carries steady current I. So we need to find here the magnetic field at this point. The magnetic field is B due to the long wire carrying steady current I. Okay, now magnetic field at this point due to this wire is mu naught I divided by 2 pi r. Okay, mu naught I by 2 pi r. So therefore magnetic field B is inversely proportional to r. Okay, so magnetic field varies as you move away from this wire. Okay, infinitely long straight wire carrying steady current I. So B is directly proportional to 1 by r, okay, or inversely proportional to r. So the magnetic field varies as r, 1 by r, right? So option B is the correct answer. Okay, how do you draw B versus r graph? If you draw B versus r graph, this is how it looks like, B versus r graph. Okay, yeah. Next question, question number 154. A magnetic needle is kept in non-uniform magnetic field. It experiences. Okay, we know that when you keep the magnetic needle in a uniform magnetic field, it experiences torque, right? Isn't it? Net force will be 0, but it experiences torque, right? Isn't it? But in non-uniform magnetic field, it experiences force as well as torque. Okay, it experiences torque as well as force. Here, the magnetic needle in non-uniform field, right? Non-uniform magnetic field, it experiences torque as well as force, right? Torque as well as force. Option A says neither a force nor a torque. Wrong. Option B, a torque but not a force. So this one is also wrong. Option C, a force but not a torque. Wrong. Option D, a force and a torque. Correct. Right? Option D is the correct answer. Yeah. Next question. Question number 155. The magnetic dipole moment of a current loop is independent of. Magnetic dipole moment of a current loop is independent of. Let us write the formula of magnetic dipole moment. M equal to N into I into A. N is number of turns, I is current in the loop, A is area of the loop. Okay. So let's check each option. Here, option A says magnetic field in which it is lying. Correct, right? So it is independent of magnetic field in which it is lying, right? Isn't it? Is there any B term, that is magnetic field term? No, right? So option A is the correct answer. Okay, it depends on number of turns, area of the loop, current in the loop. Yeah, number of turns, current in the loop, sorry, area of the loop, okay, current in the loop. Understood? So option A is the correct answer. Yeah, next question. Question number 156. A solenoid has core of a material with relative permeability 500, that is mu r equal to 500, and its windings carry a current of 1 ampere, I equal to 1 ampere. The number of turns of the solenoid is 500 per meter, that is the value of N equal to 500 per meter. the magnetization of the material is nearly. That is, we need to find the value of M, magnetization, right? Magnetization M is equal to susceptibility Xi into H, magnetic field intensity, right? So let us find susceptibility and magnetic intensity. So psi is equal to mu r minus 1. This formula everybody knows, right? Magnetic susceptibility is equal to mu r minus 1. Actually, mu r is equal to susceptibility plus 1. So susceptibility is equal to mu r minus 1, right? And H equal to N into I, right? Now susceptibility is equal to mu r. Mu r is 500 minus 1, which is equal to 499, right? And H is equal to N. N is 500 per meter into I. The value of I is 1 ampere. So which is equal to 500 only, right? Now magnetization M is equal to 499 into 500. Solve this, you will get M approximately 2.5, okay? 2.5 into 10 to the power 5 ampere meter, okay, ampere per meter. 2.5 into 10 to the power 5 ampere per meter. So option B is the correct answer, okay? Yeah, next question. Question number 157. The normal magnetic flux passing through a coil changes with time according to the equation phi equal to 6t square minus 5t plus 1. So this is the magnetic flux, okay? It is changing with time. So function of the magnetic flux is in time t, right? Isn't it? What is the magnitude of the induced current at t equal to 0.5 second if resistance of the coil is 10 ohm? Okay, resistance of the coil is given, so we need to find induced EMF, or sorry, induced current at t equal to 0.5 second, right? Okay, so induced current I is equal to induced EMF divided by resistance of the coil, right? So induced current is equal to induced EMF in magnitude, it is d phi by dt, okay, whole divided by R. R is 10 ohm. Now I is equal to, what is d phi by dt? D phi by dt is differentiation of phi with respect to t. So let us differentiate phi with respect to t, that is magnetic flux with respect to t. Differentiation of 6t square is 6 into t square is 12t, and differentiation of phi t is 5, okay, whole divided by, here at time t equal to 0.5 second, right, whole divided by 10. So I is equal to 12 into 0.5, 12 into 0.5 is 6, right? 6 minus 5 is 1, 1 divided by 10, which is equal to 0.1. So induced current is 0.1 ampere, okay? So the correct option is D. Question number 158. An electron moves on a straight path xy as shown in figure, okay? The ABCD is a coil adjacent to the path of electron. What will be the direction of current, if any, induced in the coil? Okay, so we need to find the direction of the induced current in the coil, okay? Here the electron moves, right? Isn't it? This is the direction of the electron, right? So we know that the direction of the electric current is opposite to the direction of the electron, right? Isn't it? So the direction of the electric current is in this way, okay? Now what is the direction of the magnetic field? Here the direction of the magnetic field is outward from the plane, right? The direction of the magnetic field is outward from the plane, right? So initially the magnetic field increases, right? Here the direction of the magnetic field is outward from the plane. So as electron moves towards this coil, okay, in this way xy path, the direction of the magnetic field, the magnetic field increases, right? The magnetic field or magnetic flux through this coil increases. isn't it? So to oppose the increase in magnetic flux, induced EMF produced in such a way that, so it opposes the increase in magnetic flux, right? Isn't it? So here the magnetic field due to the induced EMF is into the plane, right? Induced EMF, here the magnetic field due to the induced current. Induced current means here induced current produced because of the induced EMF, right? Isn't it? So the direction of the magnetic field is into the plane. This is due to induced current, right? So what is the direction of the induced current? The direction of the induced current is from ADCB, right? ADCB, isn't it? ADCB. Okay. Now as electron moves away from the coil, magnetic field decreases, right? Isn't it? Magnetic field or magnetic flux through this coil decreases. Again, to oppose that, induced EMF will be produced in the coil, right? Or induced current produced in the coil, right? So that induced current produces magnetic field, right? It opposes the decrease in magnetic field, right? So what is the direction of the magnetic field due to the induced current? So it will be outward from the plane only, right? Isn't it? Outward from the plane. Now what is the direction of the induced current? Now the direction of the induced current is from ABCD, right? ABCD. That is the current reversed, right? The induced current reversed, isn't it? So let's look at the option A. The current will reverse its direction as the electron goes past the coil. Correct, right? As electron goes past the coil, first what happens? Here the current, the direction of the current. Okay, here as electron moves towards the coil, the direction of the current is ADCB, induced current. Okay, ADCB. As electron moves past from the coil, the direction of the induced current will be ABCD. Okay, the direction of the induced current reversed. So option A is the correct answer. Question number 159. Okay, the RMS value of the question number 159. The RMS value of the current in 50 Hz AC circuit is 6 ampere. The average value of AC current over a cycle. Direct question, right? We know that average value of the AC current over full cycle, over a cycle, is 0, right? So the correct option is C. Okay, the derivation is there in NCERT, so just go through the derivation. You will get the 0, the final result 0. Okay, over full cycle, the current, AC current over a cycle. Okay, next question. Question number 160. In an LCR circuit at resonance, option A says the impedance is maximum. No, actually in resonance the phase angle is 0, right? Isn't it? Phase angle is 0. Why? Because XL equal to XC, right? Tan phi equal to XL minus XC divided by R. So what is the condition for resonance? Condition for resonance is XL equal to XC, right? XL equal to XC. So tan phi is equal to 0, right? Isn't it? Tan phi is equal to 0. So option A is wrong. Option B, the current leads the voltage by pi by 2. Wrong. Actually, the phase difference is same, right? That is, both are in same phase. So option B is wrong. Option C, the current and voltage are in phase. Correct. Option C is the correct answer, right? Or correct option, isn't it? Option C is the correct option. The current and voltage are in same phase. Okay, yeah, voltage are in phase. Yeah. Next question. Question number 161. A current of 5 ampere is flowing at 220 volt in the primary coil of a transformer. If the voltage produced in the secondary coil is 2200 volt and 50% of power is lost. Here current in the primary coil is 5 ampere at 220 volt. Okay, and current in the secondary coil, or current we need to find here current in the secondary coil, okay, so it is at the voltage 2200 volt, right, isn't it? Here the voltage produced in the secondary coil is 2200 voltage, and 50% of the power is lost, right? So then the current in the secondary coil will be, that is, we need to find Is. Okay, we need to find the value of Is. Here output power is equal to 50% of the input power, right? 50% of the power is lost, right? That is, output power is equal to 50% of the input power, right? So what is the output power? Output power is Vs into Is, right? What is the input power? Input power is Vp into Ip. 50% is 0.5 into Vp Ip, right? So we need to find the value of Is. Is equal to 0.5 into Vp. Vp is 220 volt, right? 220 into Ip, that is 5 ampere, divided by Vs. Vs is 2200 volt. So 220 by 2200 is 0.1, right? So Is is equal to 0.5 into 0.1 into 5. So Is is equal to 5 into 0.1 is 0.5. 0.5 into 0.5 is 0.25. So 0.25 ampere. Okay. So the correct option is A. Understood? Yeah. Next question. Question number 162. A vessel of height 2d is half filled with the liquid of refractive index root 2. Okay. Let's say mu1 is equal to root 2. And the other half with the liquid of refractive index n. Okay, mu2 is equal to n. The given liquids are immiscible. Then the apparent depth of the inner surface of the bottom of the vessel, neglecting thickness of the bottom of the vessel, will be. Okay, we need to find apparent depth of the inner surface of the bottom of the vessel, right? Let us draw the diagram. Okay, here the second liquid, okay, the refractive index is n. The first liquid, refractive index is root 2. Okay, so from the top you are observing, right? From the top you are observing the bottom surface of this vessel, right? So because of these two liquids, it seems like the bottom surface seems like raised, right? Bottom surface seems like raised, isn't it? Raised. So we need to find apparent depth, right? Apparent depth of the inner surface of the bottom of the vessel, right? Okay. So for first liquid, okay, we know that refractive index mu is equal to real depth divided by apparent depth. Everybody knows this one, right? Refractive index equal to real depth divided by apparent depth, right? So now for the first liquid, here mu1 is equal to real depth, right? Real depth is d, right? Real depth is d, isn't it? The total height is 2d, half is filled with first liquid and the other half is filled with second liquid of refractive index n. Refractive index of the first liquid is root 2, right? So mu1 equal to real depth d divided by x1. Okay, x1 is the apparent depth. So now x1 is equal to d divided by mu1, that is d by root 2, right? Similarly, for second liquid, x2 is equal to d by n, right? So now total apparent depth, here total apparent depth is equal to x1 plus x2, right? Now total apparent depth, that is x, okay? Total apparent depth is x. X is equal to x1 plus x2, right? That is d divided by root 2 plus d by n. Now apparent depth, that is total apparent depth, x equal to d into n plus root 2 divided by n into root 2. That's it, right? So the correct option is B. Okay. Next question, question number 163. The speed of light in medium m1 and m2 are 1.5 into 10 to the power 8 meter per second and 2 into 10 to the power 8 meter per second. Let's say v1 is the velocity of the light in medium 1 and v2 is the velocity of the light in medium 2. Okay, respectively. A ray travels from the medium m1 to the medium m2 with an angle of incidence theta. The ray suffers total internal reflection, then the value of the angle of incidence theta is. Okay, so what is the condition for total internal reflection? The condition for total internal reflection is I, that is angle of incidence, must be greater than critical angle IC. Okay, angle of incidence is theta, so sin theta must be greater than sin C. Okay, we know that sin C is equal to 1 divided by mu, right? So in this case, mu is refractive index of the first medium with respect to the second medium. So sin C is equal to mu2 divided by mu1, right? 1 by mu is 1 by mu1 by mu2. 1 by mu1 by mu2 is mu2 by mu1, right? So sin C is equal to mu2 by mu1. Now here mu2 divided by mu1 is equal to, here refractive index of the second medium and first medium is not given, right? But the velocity of the light in first medium and second medium is given. Now we can easily find the refractive index of the second medium and first medium, right? How we can find? We know the refractive index is the ratio of the velocity of the light in vacuum to the velocity of the light in medium. So mu2 is equal to C divided by V2 whole divided by mu1 is C divided by V1. Okay, so now mu2 divided by mu1 is equal to V1 divided by V2. V1 is 1.5 into 10 to the power 8 meter per second, right? Divided by 2, V2. V2 is 2 into 10 to the power 8 meter per second, right? 10 to the power 8, 10 to the power 8 will get cancelled, right? 1.5 is 3 by 2. So 3 by 2 by 2 is 3 by 4. So mu2 divided by mu1 is equal to 3 divided by 4, right? Okay, so now sin theta must be greater than 3 divided by 4, right? So theta must be greater than sin inverse of 3 by 4, sin inverse of 3 by 4. Okay, now this is the condition. So next, here the correct option is A, right? Greater than theta is greater than sin inverse of 3 by 4. Okay. Next question, question number 164. Radii of curvature of converging lens are in the ratio 1:2. Okay, so in magnitude R1 is equal to R, R2 is equal to 2R. Okay, in magnitude, its focal length is 6 centimeter. Focal length F equal to 6 centimeter. And the refractive index is 1.5. Your mu is 1.5. Okay, relative refractive index, that is refractive index of the lens with respect to the air. Okay, 1.5 by 1, that is 1.5. Then its radii of curvature are dash respectively. Okay, we need to find the value of R1 and R2. Okay, focal length, refractive index, all are given, right? So we need to use the lens maker's formula, that is 1 divided by F is equal to relative refractive index mu minus 1 into 1 divided by R1 minus 1 divided by R2. Okay, here R2 is equal to minus 2R and R1 equal to R. Okay, now 1 divided by F is 6 centimeter, right? 1 by 6 is equal to, here mu is here 1.5, right? 1.5 divided by 1, that is 1.5 minus 1 into 1 divided by R minus 1 divided by minus 2R. So minus into minus plus, so this will be 1 by R plus 1 by 2R, right? Now 1 by 6 is equal to 0.5 into 1 by r plus 1 by 2r, right, which is equal to 3 divided by 2r, right, 3 by 2r. Now we need to find the value of r, right, isn't it? Here, solve this, you will get r equal to 4.5 centimeter. Okay, here r equal to 4.5 centimeter, so which is equal to r1, right? So r2 is equal to 2r, right? So 2 into r is 9 centimeter. R1 is 4.5 centimeter, R2 is 9 centimeter. So the correct option is D. Okay. Question number 165. A beam of light consisting of red, green and blue colors is incident on a right angled prism. Here this is the right angled prism. Okay. Blue, green, red. These three lights incident normally on the face AB, okay, of the right angled prism. The refractive index of the material of the prism for the above red, green and blue wavelengths are 1.39, 1.44 and 1.47 respectively. The prism will, option A says, not separate the three colors at all. Okay, let's check which color, the prism will separate which color, okay, whether it is blue, green or red. Yeah. Here, what is the condition for total internal reflection? The condition for total internal reflection is I is greater than IC, right? See, these three colors are incidenting normally, right? Isn't it? So there is no refraction, right? There is no refraction. Isn't it? There is no refraction. So sine I, here sine I is greater than sine C or sine IC, right? We know that sine C is equal to 1 divided by mu, right? 1 by mu. Mu is the refractive index of the prism material. Now sine C is equal to sine 45 degree, right? Sine 45 degree. So where does 45 degree came from? Here the 45 degree is the angle of incidence of the blue color, green color and red color for face AC, right? Isn't it? The angle of incidence is 45 degree, right? Isn't it? On face AC. So now sine 45 degree is equal to 1 divided by mu, right? So mu is equal to 1 divided by root 2, right? Mu is equal to root 2. Mu is equal to root 2. Okay. Now refractive index of the red, green and blue wavelengths are given, right? Isn't it? So refractive index of the red is lesser than mu, right? And refractive index of the blue wavelength is lesser than mu. Refractive index of the green wavelength is lesser than mu, right? So here refractive index of the blue and green wavelength greater than mu, okay, greater than mu. Okay, so therefore blue and green wavelength undergoes total internal reflection, right? Blue and green wavelength undergoes total internal reflection, right? Isn't it? And red color does not undergo total internal reflection, right? Isn't it? So the prism will separate red color, okay, from the blue and green, right? So it will separate the red color. So option B says separate the red color part from the green and blue colors. Correct, right? So option B is the correct answer. Okay. Next question. Question number 166. Resolving power of a telescope increases with. So what is the formula of the resolving power? Resolving power is equal to here D divided by 1.22 lambda, right? D divided by 1.22 lambda. Here D is the aperture of the objective, right? If you increase the value of the D, resolving power increases. So option A says increase in focal length of the eyepiece. Wrong. Option B says increase in the focal length of the objective. Wrong. Option C says increase in aperture of the eyepiece. Wrong. Increase in aperture of the objective. Okay. Option D says increase in aperture of the objective. So option D is the correct answer. Okay. Next question. Question number 167. Wavefront is the locus of all point where the particles of the medium vibrate with the same phase. Okay. Direct question. Right. Option A is the correct answer. Yeah. Next question. Question number 168. The observed diffraction, the size of, to observe diffraction, the size of the obstacle. Here, the size of the obstacle should be in order to the wavelength of the light, right? Isn't it? So, it's the size of the obstacle should be or comparable to the, here should be of the order of the wavelength, okay, or the size of the obstacle comparable to the wavelength, size of the wavelength, right, or comparable to the wavelength, okay. So option B is the correct answer, should be of the order of the wavelength. Yeah. Next question. Question number 169. The maximum velocity of the photoelectron emitted by a metal is 1.8 into 10 to the power 6 meter per second. Vmax, that is maximum velocity of the electron, is 1.8 photoelectron, okay, 1.8 into 10 to the power 6 meter per second. Take the value of specific charge of the electron is 1.8 into 10 to the power 11 coulomb per kg, that is E by m is equal to 1.8 into 10 to the power 11 coulomb per kg. Then the stopping potential, okay, we need to find the stopping potential, right? So we know that E into Vs is equal to maximum kinetic energy of the electron, right? Isn't it? Vs is stopping potential, right? That is this much energy we need to, or this much potential we need to apply, the negative potential, okay, we need to apply to the anode plate, okay, so that it will stop the photo current, right? Now we need to find Vs. Vs is Ke max, that is half m into V square divided by E, right? E by m is given, right? Vs is equal to half into, here m by E is 1 divided by 1.8 into 10 to the power 11 coulomb per kg into V square. V square is here 1.8 into 1.8 into 10 to the power 12 meter square per second square, okay. Here 1.8 will get cancelled, right? 1.8 by 2 is 0.9, right? 1.8 divided by 2 is 0.9, 0.9, right? So Vs is equal to, now solve this, you will get 9 volt, okay. So the correct option is C. Question number 170. When a piece of metal is illuminated by a monochromatic light of wavelength lambda, then the stopping potential is 3 Vs. When same surface is illuminated by light of wavelength 2 lambda, then the stopping potential becomes Vs. The value of threshold wavelength for photoelectric emission will be, threshold wavelength, let's say lambda naught is the threshold wavelength, okay. So now for the first situation, that is when the monochromatic light of wavelength is lambda, the stopping potential is 3 Vs, okay. This is the first situation. Let's write the photoelectric equation. The photoelectric equation is Hc by lambda, that is energy of the incident photon, is equal to maximum kinetic energy of the photoelectron plus phi. Phi is the work function, okay. So now for first situation, Hc by lambda, lambda is wavelength of the incident photon, is equal to maximum kinetic energy of the photoelectron is E into 3 Vs plus phi. Phi is Hc by lambda naught. Let's say this is the first equation, okay. Now for second situation, let's write photoelectric equation. Hc by 2 lambda is equal to E into Vs plus Hc by lambda naught, right? Now I can write this equation as hc by lambda naught is equal to hc by 2 lambda minus E into Vs, right? Let's say this is the second equation. Now substitute second equation to the first equation, right? Now hc by lambda is equal to 3 times EVS plus hc by lambda naught. hc by lambda naught is hc by lambda minus EVS. Now solve this, you will get hc by lambda is equal to 2 times EVS, right, plus hc by 2 lambda. Okay, this is hc by 2 lambda, right? Now solve this, we will get E into Vs equal to hc by 4 lambda. Now we have the expression of EVS, right? Now substitute the EVS, expression of EVS to the second equation, right? This equation. Now hc by lambda naught is equal to hc by 2 lambda minus hc by 4 lambda. Now hc will get cancelled, right? Finally, lambda naught is equal to 4 lambda. Solve this equation, you will get the threshold wavelength lambda naught equal to 4 lambda. So the correct option is C. 171. Rutherford's atomic model could account for stability of the atom. Wrong. Actually, it could account for the positively charged central core of an atom. Okay. So origin of the spectra, wrong. The correct option is C, the positively charged central core of an atom. Okay. Concept of stationary orbit, again, this one is also wrong. So the correct option is C. Direct question, right, from the Rutherford's atomic model. Question number 172. The amount of energy required to separate a hydrogen atom into a proton and an electron. Again, the direct question, right? The amount of energy required to separate the hydrogen atom into a proton and electron is 13.6 electron volt. That's it, 13.6 electron volt. Okay. So option B is the correct answer. Yeah. Next question. Question number 173. An electron of a stationary hydrogen atom makes this transition from the fifth energy level to the ground level. Okay. Here NF, here the fifth energy level, right? The final is first one and initial is fifth one. Ni is equal to 5, Nf is equal to 1. The velocity that the atom acquired as a result of photon emission will be. Okay, we need to find velocity of the atom that required as a result of photon emission will be. Mass of the hydrogen atom is m, r is the Rydberg constant, h is Planck's constant. Okay, we know that here de Broglie wavelength lambda is equal to h divided by p, right? In this case, p is the momentum of the atom, right? So here h, here p is m into v, right? P is m into v, momentum of the atom, right? So I can write this equation as p equal to h divided by lambda, right? So p is m into v, which is equal to h divided by lambda. So v equal to h divided by m into v, sorry, m into lambda. Okay, h divided by m lambda, m lambda. Okay, h and m we know, right? So we need to find lambda, right? Isn't it? So we know 1 by lambda, the formula 1 by lambda, that is the wave number 1 by lambda is equal to r into, r is Rydberg constant, r into 1 divided by nf square minus 1 divided by ni square. Nf is the final energy level, ni is initial energy level of the electron. Okay. Now 1 divided by lambda is equal to r into nf is 1, right? 1 by 1 minus ni is 5, right? So 5 squared, that is 25. So 1 divided by lambda is equal to 24r divided by 25. So now substitute 1 by lambda to this equation. Now velocity v is equal to h divided by m into 1 by lambda, right? 1 by lambda is 24r divided by 25. right? Finally, velocity v is equal to 24 h divided by 25 m. So the correct option is A. Okay, 24 RH divided by 25 m. Yeah, next question. Question number 174. The volume of the nucleus is directly proportional to the simple one, right? Volume of the nucleus is 4 by 3 by r cube, right? R is the radius of the nucleus. We know that radius of the nucleus r is equal to r naught, the empirical constant. Okay, r naught is empirical constant into a to the power 1 by 3, right? So r cube will be equal to r naught into a. So volume of the nucleus is directly proportional to a, right? A is mass number. So the correct option is A. Next question, question number 175. A force between two protons is same as the force between the proton and neutron. The nature of the force is, the force between the two proton is same as the force between the proton and neutron, right? That is the nuclear force, right? Strong nuclear force, not just nuclear force, strong nuclear force. Strong nuclear force. The nature of the force is strong nuclear force. So the correct option is D. Okay, not gravitational force, not weak nuclear force. Weak nuclear force occurs when beta decay takes place. Okay, and electric force, again this one is also wrong, absolutely wrong. So the correct option is D. Next question, question number 176. In which of the following statements the obtained impure semiconductor is of p type? Option A says gallium is doped with bismuth. Okay, if you want to get p type, then we have to dope the semiconductor, okay, intrinsic semiconductor like silicon and germanium, okay, silicon and germanium with trivalent, okay, trivalent atoms. So that is boron, aluminum, okay, boron and aluminum, and then gallium, boron, aluminum and gallium, okay. So option A says germanium doped with bismuth, wrong. Option B says silicon is doped with antimony, wrong. Option C says germanium doped with gallium, correct. Option D says silicon is doped with phosphorus. Here the phosphorus is pentavalent, right? So we will get n-type semiconductor, not p-type semiconductor. Okay, if you want to get n-type, then dope with pentavalent atoms, okay, or pentavalent impurities. Yeah. Next question, question number 177. In the following figure, the diodes which are forward biased are, okay, so these are the given diagram, right? Though here, so this is PN junction diode, right? Isn't it? So in PN junction diode, okay, P is always connected to the, okay, for forward bias, P is connected to the higher voltage, okay, or higher side of the voltage, and N side is connected to the lower side of the voltage or lower voltage, okay. So look at the option A. Here N is connected to the lower voltage compared to the P side, right? Here P is connected to the higher voltage, isn't it? So option A is correct, option B is wrong, right? Because P is connected to the -10 voltage and N is connected to the ground, that is 0 voltage, right? So 0 is greater than -10, so option B is wrong. Option C, yeah, this one is correct, right? P is connected to the higher voltage, -5 voltage. -5 is greater than -12, right? So option C is correct. N is connected to -12 voltage, right? Yeah. Option D, here option D is also wrong, right? Because here P is connected to the ground, that is 0 voltage, and N is connected to +5 voltage. Here N is connected to higher voltage compared to the P side, right? Isn't it? P, right? So option D is wrong. So the correct figures are A and C. So option C is the correct answer. Question number 178. In semiconductors at room temperature, option A says the conduction band is completely empty. Wrong, right? Actually, conduction band is completely filled, right? And valency band is partially filled, right? So option A is wrong. Option B, the valency band is partially empty and the conduction band is partially filled. So this one is wrong. The valency band is completely filled and the conduction band is partially filled. This is the correct answer, right? Isn't it? C is the correct answer. Question number 179. The velocity of electromagnetic radiation in vacuum of permittivity epsilon naught and permeability mu naught is given by. The direct question, right? From the Maxwell equation, velocity of the light in vacuum, V equal to C equal to 1 divided by root of mu naught into epsilon naught. That's it. So the correct option is A. Question number 180 and the last question. What is the de Broglie wavelength of the electron accelerated through a potential difference of 100 volt? So we know the formula, right? The de Broglie wavelength of the electron accelerated through a potential difference V, right? That is lambda is equal to 12.27 divided by root times V, the potential difference. Okay, V is the potential difference, angstrom. So lambda is equal to 12.27 divided by root 100. Potential difference is 100 volt, right? In angstrom. So the value of lambda is equal to 1.227 angstrom. So the correct option is D. Okay. Yeah, the last question. Everybody understood how to solve the problem or how to approach the problem, right? This is the direct question. Okay, these kind of the questions only will given in KCET. Okay, they will only give these kind of the question. Okay, yeah. Okay, thank you so much. If you love this video, please like and share, and if you want to watch more such kind of video or such type of video, please subscribe. Thank you.